Hello, welcome everyone to my channel. Today we'll be talking about the normal distribution. Want to know how to score really well when it comes to the normal distribution. Why do we need a normal distribution? Basically, it's because it's the only distribution in S1 statistics that can be used to approximate the others. Okay, so when we really understand it, we are good to go. So in this video, this is what we are going to do. We are going to talk about everything the normal distribution has to offer. Okay, we are going to solve different questions, and then we are going to also solve the questions on approximations. Okay, we use normal to approximate binomial, and then we will use normal to approximate geometric. Okay, so I hope you know a little bit about normal distribution, because this is not really a tutorial on normal distribution. This is a tutorial on how to solve questions on normal distribution. So I hope you know something small about it. Well, let's dive right into it. Okay, so the first question says that the times they taken to swim 100 meter by members of a large swimming club has a normal distribution, with the mean to be 62 seconds and the standard deviation to be 5 seconds. These are the important things that we need. Okay, so the first question says find the probability that a randomly chosen member of this club takes between 56 and 60 seconds to swim the 100 meters. Now, at this stage, this is what I want you to do. Grab your calculator, okay? Then the next thing that you have to do is to download the worksheet that I've attached to this video, and then also download the how do we call it? The Z table that I've attached to it, okay? So that everything will be great. All right, so let's get into it. Now they say that it's between these two values. Okay, so the probability, let's say that times taken by these people follow the normal distribution, and then the variable that we are dealing with is x. Okay, I like to write x. So x is in between 56 and then 66. Okay, that is it. Now the formula used to standardize any random variable is given as, okay, z is equal to x minus mu over the standard deviation. Okay, so this is really important, and this formula we are going to use it throughout. Okay, all right, so that would mean that we have where the mu, okay, this mu is the mean given in the question, and then this sigma is a standard deviation. Okay, so that means we have 56 minus the mean. Now the mean is 62 seconds divided by the standard deviation of 5 is less than z is less than 66 minus the mean of 62 divided by a standard deviation of 5. Right, like I said, grab your calculator, because these things are calculator work. So I have 56 minus 62 over over 5, and that will give you negative 1.2 is less than z is less than, then we have 66 minus 62 divided by 5, that gives us 0.8. Okay, now whenever you are working something like this is a rule I need you to keep in mind. Take phi of the positive number minus 5 the negative number. Okay, always the bigger one minus the smaller one. Therefore phi of 0.8 minus phi of the smaller number, which is negative 1.2. Now there's one thing I need to tell you. The phi of a negative number also means 1 minus phi of the positive of the same thing. Okay, so you have minus into bracket 1 minus phi of 1.2. Okay, so at this stage what you can do is that you can grab the Z table from your MF19 book, okay, formula book. It will be provided by Cambridge, so don't worry about it. And if you don't have a copy, I'll link it in the description so that you can easily access it. So 0.8 is actually 0.8 0.7881 minus 1 minus. Now 1.2 is also 0.8849. 0.8849. Okay, so let's do this. From here, let's come here. Okay. So that means I have 0.7881. Now I have in the bracket I have 1 minus 0.8849, and that gives me minus 0.1151. Okay, so I have 0.7881 minus 0.1151. Okay, and that will give me 0.673. So that is the probability that a randomly chosen variable, the probability, between 56 and then 66 will give us that. Now, the next thing is that they are telling us 13%, okay, of the members of the club take more than t seconds to swim. Okay, we should find the value of t. Well, if 13% are taking more than t, we have already argued that let x be the variable we are dealing with. So I'm going to use x. I don't want to keep changing anything. So x is more than t, right? Because that's what they're saying. But it's not just t, it's in minutes. This is the problem with these questions. Okay, that's the only trick. This is minutes. Okay, and then in the question they gave it to us in seconds. So that means that we have to go and change the t minutes to t seconds, and that would be 60t, okay, because of the conversion. 1 minute and 60 1 minute, I think 60 seconds is equal to 1 minute. So what I'm going to do is that I'm going to clean this guy and then put 60t there, because everything must be in seconds. Okay, so that would mean that, okay, so this probability is actually equal to 0.13. That is what we were told, that it is less than, it's actually 13%, so that's it. Then the next thing you want to do is to standardize it. So the probability of z is greater than 60t minus the mean. Now the mean, they gave it to us as 62. 62 divided by the standard deviation of 5 seconds, okay, is equal to 0.13. Okay, now the z table was prepared with the less than in mind, so it's always read to the left. If you have z greater than, that means you have to do small manipulation here. Okay, so if it is greater than, then it is 1 minus 5 of this particular value. Okay, so 1 minus 5 into bracket 60t minus 62 all over 5 is equal to 0.13. Great. Now what you want to do at this stage is to have move the 1 to the other side. So you have negative 5 60t minus 62 over 5 is equal to 1 minus that guy. 0.13 minus 1 will give us negative 0.87. So negative cancel out. All right, so you have 60t minus 62 over 5 is equal to the 5 to the negative 1 of 0.87. Okay, now what this means when we say phi inverse or phi to the negative 1, that means that you read out from the table. So you go and locate 0.87 from the table, and then you read the z value from there. Right, so the first thing you want to do is to check out if this particular value is a critical value, and it's not. 0.87 is not a critical value. So let's go to the main table and then read that. So 0.87, some of you are really fast with the reading, so you might get it before I do. 0.87, I have seen 0.8708, so that is too much. So we go to the value below that. That's 0.8686. Okay, so what you do is that take 87, make it 4 decimal places, okay, or just make it 4 figure. So 8700 minus what you can see from the table, omit the 0 point something something. Just write 8686. So that means you have 14 left, okay? But the 0.8686 is actually 1.12, okay? So we have, for this, we have 1.12. Okay, now the 14, we go to the add session, okay? The add session, the 14 is on, let me be very careful with this. 14 is on 7. So the Z value is 1.127, okay? All right, so now let's write here. So we have 60t minus 62 all over 5 is equal to 1.127. You solve for t, so that would be, let's see, 60t is equal to, I would multiply that by 5, okay, and then I would add 62. After that, t, I would divide by 60. Okay, all over 60. Then, let's see what a calculator has to offer. 5 into bracket 1.127 plus 62 all over 60. Great. And the calculator says the answer is 1.12725. Basically, Cambridge will be interested in maybe 3 significant figures. So t is 1.13. That's cool. Okay, so that's the end. That's 5/3 October, November 2020. Okay, so that's how we solved the question. They said find the value of t, so we found t. Now, let's move on. This is a different question. There, we are told that the time in hours that David plays his games, machine, blah, 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 follows a normal distribution with the mean and the standard deviation as that. Okay, so we should find the probability that he plays more than 4.2 hours. So now we go back to the question. The mean and the standard deviation that they gave us, is it in hours? And yes, because it says time in hours. Okay, so that means there's no need to do any conversions. You just use the values over there. So I'm just going to still use x. It says it's more, so that means it's greater than 4.2. So we need to find this probability. We standardize it. Okay, so we have z is greater than 4.2 minus 3.5 over 0.9. And this is calculator work. So z is greater than what value? 4.2 minus 3.5 over 0.9, and that, ladies and gentlemen, gives us 0.778. okay, as a recurring decimal, but it just needs 3 decimal places, a minimum of 3 decimal places to work. Now I told you that when you have greater than, okay, it's just 1 minus phi of that particular value. So you have 1 minus phi of 0.778. If it's less, I just do phi of that value. But if it's greater than, I always do 1 minus. Okay, keep that in mind. Okay, so let's go to the table and read 0.778. So on the table, we can get 0.7, and then we trace that to the 0.77. Now 0.77, ladies and gentlemen, will give us, let me do this rough work somewhere here. That's 0.7794. Great. Okay, and then the next thing that we want to do is to, the last number is 8, right? So 8 over here is what? I think that's 24, 0.7. Okay, that's 24. So we add 24 to it. Okay, not just take 7794 plus 24. It means you are looking at 0.7818. All right, so 1 minus 0.7818, that gives us 0.2182. Okay, you can leave your answer like this, and then you are good to go, or you can leave it in 3SF. That's also fine. This is actually a an exact value. Okay, so you can leave it like that. Okay, so the next question here says that 90% of the days David plays his game on the machine for what, more than t hours. So we should find the value of t. So the argument is that x is greater than t. Okay, that is really important because we are told that it's more than what, t hours. Now, what is the probability that he plays more than t hours? We are told is 90%, and proportions and probabilities are the same. So the probability that he plays greater than t is actually 0.9. Okay, so then you standardize it. So you have the probability of z greater than t minus the mean. And the mean, ladies and gentlemen, was 3.5, and the standard deviation 3.5, standard deviation 0.9. Okay, so this whole thing is equal to 0.9. Now that would mean that 1 minus, I told you if it is greater than, it means 1 minus. So you have 1 minus t is 3.5. Excuse me. All right. 0.9 is equal to 0.9. Okay, so what we do is that let's move the 1 to the other side. So you have negative phi t minus 3.5 over 0.9. Well, 0.9 minus 1, that will give you negative 0.1. Now, what you want to do at this stage, negative cancel out. So you have t minus 3.5 over 0.9 is equal to phi to negative 1, okay, of 0.1. But you see, the problem is that when you go to the z table, you want to read inside out, that's the inverse, or phi to the negative 1, you would not get negative 0.1 over there. So what you do is that you do negative phi of, then into bracket 1 minus that value, because once you cannot read it on the z table, it means that it is on the left hand side, because this z table starts from 0.5, so that's half of it, okay, and everything over there. So if you cannot find it, it means it's on the left hand side, okay, of the mean, and the mean is 0 now when you normalized it. So that means that we do t minus 3.5 over 0.9 is equal to negative phi of negative 1 minus 0.1. This is really important. When you cannot read it from there, make sure that you use this identity. It's really important. Negative phi to negative 1 into brackets 1 minus the value that you already had. And that will give you t minus 3.5 over 0.9 is equal to negative phi of 0.9, okay? Now 0.9 is a critical value, so when you go to where the critical values are, you just see 0.90, and that has a z value of 1.282, so you don't have to worry yourself to read it from the table. Okay, so you have t minus 3.5 over 0.9 is equal to negative 1.282. Then you make t the subject. All right, so that would mean that I have t is equal to 0.9 to bracket negative 1.282 plus 3.5, and that you just put it on a calculator, and they have 0.9 into bracket negative 1.282 plus 35, okay, and that will give you 33.8, okay. That is if you are using 3SF 33.8. I know you get 33.86, sorry, 8462, but you don't need that. Just 3SF will be great for you. Okay. Now, the next thing that, okay, so they gave us a lot of space. I was writing this way, but in the exam, you have a lot of space for that. Okay. So the next question that we want to look at is the C part. We are not done. The C part says calculate an estimate for the number of days in a year, and they are very specific. Okay, Cambridge doesn't give those confusion things. People, can take 365 days. Someone will take 364. So Cambridge is very specific that it should be 365. So if you use 364, you are wrong. All right, you are going to lose marks. You wouldn't get 0 because you have to do some calculations before that. But I mean, use what you are given. That's the point. Okay. Between these two, right? Okay. So that means that x is in between 2.8, okay, and then 4.2. So let's go and normalize that. We have 2.8 minus the mean is 3.5 over the standard deviation 0.9. It's less than z. It's less than 4.2 minus 3.5 over 0.9. Great. So that would mean that just grab the calculator and let's see what we do. 2.8 minus 3.5. Okay. Let's see. There's a 2.8 minus 3.5 over 0.9, and that gives us 0.7 negative 0.778. Okay, it's less than z. It's less than 4.2 minus 3.5 over 0.9, and that is okay, the same thing, right? But just that is the positive way. Okay, but I mean the thinking is the same thing. Is, see, you have intervals, so you take the positive minus the negative. That's how it works. So phi of 0.778 minus phi of negative 0.778. Okay, so that would be phi of this minus. Now I told you that if it is a negative, there's phi of the positive thing. So you have 1 minus phi of 0.778. Okay. So what you just have to do is to go to the z table, read 0.778. I think we have actually looked for 0.778 in one of our calculations. Yes, we did. This is it. So we got 0.7818. So we don't have to go back there. So this is 0.7818 minus, into bracket, 1 minus 0.7818. So you can expand it if you want. I mean, from here, or you can just put it on a calculator. Why do I worry myself? The calculator is there to save me from thinking, right? Yeah. Plus, I'm not a student, so I don't get to think. It's you who has to think. Okay, great. So the answer is 0.5636. So if you want to write it in 3SF, then you can leave it like this, and then you are fine. But now, remember, this is the probability, okay? But they want the number of days, not the probability. So you must be smart here. If you want to find the number of days, okay, or number of, items, is the probability times the sample that they gave you, okay? So I'm not going to use this because it's an approximated value. I'm going to use this one rather. So the probability is 0.5636 times the days that they gave us, and the days is 365. Don't go and use 364. Don't use what you've been given. Okay, so that'll be 0.5636 times 365. So I'll get 205.1, this guy, okay? So now what you do is that if you look at the days that we have here, we don't have a decimal day. So we have to round this up. So that's 206 days. Okay. Well, I know that some of you would say that, well, it is more than, calculate the estimated number of days. So you say, oh, well, it's more than 205 days. I mean, some also write it that way. They don't want to approximate, and I get it, that 206 is more than 205.7. So they will never approximate. They will just say it's more than 205 days. And I think that is a smart way to look at it, because 206 itself is a rounded, and it's like you are rounding the day. So I know that some books write this, but I actually prefer this one. Okay, so the number of days is 205. I like it that way. Okay, so I mean, those of you who are my students and you watch my video, I want you to not round the days, okay, in your final exam. All right. Now let's look at this question. It says the time's taken in minutes. So this is minutes. So we should be careful if they give us any seconds. That's the thing. For a train to travel between blah 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 and blah blah blah, huge names. I cannot mention it. Normally distributed with the mean and the standard deviation of that, we should find a probability that it takes what less than 132. So I'm always going to use X. You can change it to use K or whatever you want, but X is cool. Okay, so I'm going to standardize it. So they say it's less than, so you must use the less than sign. So that is probability of Z is less than 132 minus the mean 140 over the standard deviation of 12. Now that is for calculator to do. So that is 132 minus 140 over 12. And the calculator says the answer is negative 0.667. Great. So you have phi of negative 0.667. And the phi of a negative value means 1 minus phi of the positive value. Therefore, we have 1 minus something. So we go to our Z table and then we read 0.6. So I have 0.6 here, and then I'll correspond it to 0.6 again. That means I have 7454. Okay, plus then I add what 7 to it. So I go to the add section, I look for 7, and 7 is 23. So plus 23, and my answer is 0.7477. So 1 minus 0.7477, ladies and gentlemen, the calculator says 0.2523. So approximately you have 0.252. Okay. All right. That's if you want to leave it in 3SF, of which you must do. Okay. Now the II says that find the probability that a randomly chosen train takes more than k minutes to travel between blah 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 and blah. Then that probability is what 0.657. Do I even have that there? 675. That is really close to a critical value. Anyways, you should find the value of what? Of k. So it takes more than what? K minutes. So the probability of X is greater than K is equal to 0.675. Okay, so that means that Z is greater than K minus the mean 140, standard deviation 12. You know what? Let me confirm that. Mean 140, standard deviation 12. Great. So yeah, sometimes I make mistakes. Okay, so this 1 minus phi of K minus 140 over 12, okay, equals 0.675. So we subtract 1 from that value, and then we have negative what? I think negative 3 point something, 0.3, 0.675 minus 1. Oh God, come back. Great. So that's negative 0.325. Okay. So the negatives cancel out. So we have K minus 140 over, let's see, 12. Okay, is equal to phi to negative 1 of this particular value. Now, unfortunately, okay, this value is not in any value less than 0.5. Okay, it's not going to be in the Z table. Therefore, it means it is to the left-hand side of the mean. Therefore, we do, let me change the color so you see what we do from there going. So we have K minus 140 over 12, okay, is equal to, now it is negative phi inverse of 1 minus the value we have there. Okay, now let's continue. That is really important. Okay, keep it in mind. I will keep hammering it till it enters into your skull. All right. Okay. So that is negative phi inverse of 0.675. And let's go and read it from the Z table. 0.674 is a critical value, but 0.675 is not a critical value. So we go and then we work it out. All right. Maybe it will be really close. I think it will be really close. So 0.67. So let's go for 0.6 and let's look for 0.7. Okay, so that will give you, they actually want what, 0.67, so 67. I have seen 6736. I want 0.675. Okay, we don't have 75, but we have 0.6672. No, 0.6772. And that was given by 0.446. Okay. All right, so good. So let me do this small calculation here. These things sometimes they confuse me a lot, especially reading from the table. I don't like reading from the table. It's 675, right? So I've seen 0.6772. I don't need it. I've seen 0.6736. 0.6736. Good. That is directly below 0.675. Okay. And then that is 0.45. Okay, so I've seen 0.45. I'm left with one more thing and we are good to go. And that value was 65 minus 6736. Okay, I need 14. So I come to the add session, I'll see 14, and 14 is 4. Okay, so now this is what I have. Okay, so if you were to read a critical value, you wouldn't get, that's it. So that means that our answer is K minus 140 over 12 is equal to negative 0.454. Okay, so now we can clean this guy. Now what we do is that we make K the subject, and as K will be equal to 12 into bracket negative 0.454 plus 140. Okay, and that is calculator work. So we have 12 negative 0.454 plus 140, and that, ladies and gentlemen, is 134.552. So we can write 135. Okay, 3SF 135. That'd be great. Okay, so that is it for this particular question. Let's move on to the next one. So it says that the weights of packets of certain type of biscuits are normally distributed. What you actually need is the mean and the standard deviation. So, okay, this is quite interesting. So with this question, they didn't give us a standard deviation. They just gave us a symbol of it, which is the sigma. So, it says we should even find it. Great. So how do we approach this question? All right, so let's see. In a random sample of 6,000 packets of this type of biscuits, 225 packets weighed more than, you see, that's where the interest is. So for more than, we can say X, let X be the distribution, okay? So that more than 410, okay, will be equal to what kind of probability? Well, what is the sample? The entire thing is 6,000. And how many weigh more than the 410? 225. Therefore, the probability is 225 over 6,000. 225 over 6,000. Okay. So that we can now normalize this thing, and then we have 410 minus the mean, and the mean is 400 over the standard deviation sigma. Okay, is equal to, I think we can just divide this thing and then work with decimal, which will be great. According to my calculator, if I'm wrong, it's my calculator's fault. 0.0375. Great. So this is 1 minus phi of that's 10, right? Yeah, 410 minus 400, I think that's 10. okay, is equal to this guy. So we have negative this sigma is equal to, so 1, this answer minus 1, that will give us negative 0.9625. The negatives will cancel out, therefore you have phi 10 over sigma is equal to phi to negative 1 of 0.9625. 0.9625, is that a critical value? 9625. No, it's not. So I'm sorry, we got to go to the table and read it. Okay, so 0.9, we are looking for 9625. 9625. 9625. I've seen 9641, 9633. 9625 are actually in the table, and that's great. Straight away, so that's 1.78. 1.78. Okay, 1.78. Yeah, I'm sure of that. So that's 10. This is equal to 1.78. Okay, that's cool. So that means that we have 10 is equal to 1.78 sigma. Sigma is equal to 10 over 1.78. Sigma would be 10 over 1.78, and that, ladies and gentlemen, is 5.62. Okay, that is the value of the sigma. So it's not always that you're going to give you the standard deviation and the mean. Sometimes they'll actually ask you to find the mean and standard deviation. And there's a question in this worksheet that you will see very soon. Okay, so that's it. Then the next question says, in a random sample of what, 500, how many would you expect to have more than 1.5? Oh, deviations from the mean. That's quite interesting. Okay, so how do we solve this question? Actually, if we know the probability of the distribution, which is 1.5 standard deviation for the mean, we can multiply that by 500. Okay, so the 500, don't touch it now. Don't touch it now. Let's just go and look for 1.5 from the mean. Now, let me argue something with you here. If you have your normal distribution like this, okay, I don't want to say the thing without proving it to you. This, okay, is the mean, that's 0. Okay, now 1.5 deviations from the mean, it means that you will go to the left 1.5, you go to the right 1.5. Okay, most of you just do one side, and I'm telling you, deviations can mean you are increasing or you are decreasing. That should be here. So you can have 1.5 here. If it's to the left, it's going to be negative 1.5, okay? And you can have 1.5 here to the right. So that is the deviations. So you can have something like this, have something like that. Now, this is what happens. Two things are happening, and you are going to use both. Because if you have 1.5, okay, on both sides of the mean, then this is actually less, right? So this is where you are interested in. That's 1.5, below 1.5 of it. And then you can also work with something like this, okay? Now, because it says more than 1.5, it didn't say in between. If it were to be in between, we would have worked with the middle one. But that is not what the question is saying. The question says that it is what? More than 1.5. So it could be more than 1.5 from standard deviation. It could be way below it, okay, or way above it. Point is, it is more than 1.5 above it. Okay, so these are the two things that we are doing. So that means we are working with z is less than negative 1.5, or we are working with z is greater than positive 1.5. So these are the two things that's we are dealing with right now. Okay, so if we have this, okay, all in probability or statistics means addition. Okay, so phi of this will be phi of negative 1.5. Then we have plus phi. Oh, sorry, this is greater than. So it's 1 minus phi of 1.5. And now this phi of negative 1.5 is also 1 minus phi of 1.5 plus 1 and then minus this guy. So that means that you have 1 plus 1, that's 2, right? 2 minus 2 phi of 1.5. I hope my algebra is right. Okay, so I have 2 minus 2 into bracket 1.5. I think 1.5 is easy to read. That's 0.9332. 0.9332. And that, I'll just put everything on the calculator. All right, so that would be 0.1336. Great, so that's a probability. But they want what? A sample of 500. So we are just going to do the number of biscuits or packs or what? I mean, let's just write packs. Okay, number of packs. Okay, will be equal to 500 times 0.1336, and that is 66.5. Okay, if you want to round it, then I think that well, you will not necessarily get 67 packs, so it's just about 66. You will not get 67, so it's just about 66 packs. Okay, because it doesn't necessarily reach 67, even though it's close. I mean, but you get the idea. So, I mean, questions like these, be really careful. They said that it's 1.5, more than 1.5 of it. So, if you, from 0, okay, you go to 1.5, more than that. So, that's what you're shading. And then, if you look at the left-hand side, you go to 1.5 and then more than that. So, you are way decreasing beyond the 1.5, and then you also shade that part. So those two values are what you will use to find the probability, and then you multiply by 500 and you are good to go. Okay, so let's give this particular question a try. It says that the weight of apple of blah blah blah. I mean, the mean is 82, and then 22% of these apples have greater than what? 87. So you should find the standard deviation of that. Well, they didn't give us the standard deviation again, and they want us to find it. So that is probability of x is greater than 87 is equal to 0.22, because this is 22%. Okay, so z is greater than 87 minus the mean 82 divided by standard deviation, call it sigma, is equal to 0.22. Well, that will be 1 minus 5 of, that's 5, I believe so, over sigma is equal to 0.22. Okay, so that's negative this. Now 0.22 minus 1, that is negative 0.78. So we can say that the negatives will cancel out. So you have 5 over sigma is equal to 5 to negative 1 of 0.78. And let's see, 0.78. Is it 78? It's not. Okay, so let's go to the table and then read that value, 0.78 inside out. So I've seen 0.7881, although then I've seen 0.7852, 7823, 774, 7794. That is great. So 7800 minus 7794, that will give us 6. So, okay, so far I've seen 0.77. Okay, and so our answer is 0.772. Okay, 0.772. If I make a mistake in my reading, just comment it below there, okay, to help your colleagues. So that's 0.772. Let me check it one more time. These things are very tricky. 0.772. I believe I'm right. So I have 5 is equal to 0.772 sigma. And then sigma is equal to 5 over 0.772. that would give us, all right, that would give us, let's see, 5 over 0.772, and our answer is 6.48. Okay, 6.48 is great. Okay, so that's the standard deviation in question. Now, find the probability that the weight of a randomly chosen apple varies. It differs from the mean by less than what, 4 grams. Okay, so now this is what you are going to do. If you have the normal distribution like this, and this is the mean, say 0, and then so you are going to the left by 4 grams, and you are going to the right by 4 grams. And now the mean, if you do not standardize, that's if you standardize it. But if you are not standardize it, then it is not going to be 0, because the mean could be, what they gave us, what is it, 82. So if the mean is 82, then if you go 4 to the left, that will be what, 78, I think so. I don't need a calculator for that. If I make a mistake, correct yourself. And then to the right of that, that will be 86. Okay, so what you would do is that you can write that, then you have 78 is less than x is less than 86, because you took the mean and then you subtracted 4 and you added 4 to it. But that's a long process, because at the end of the day you would have to now come and standardize it, and no, long process. But sure, you get your 4 marks. But I don't want to do that. Okay, I want you to have options, so let's do it in 2 ways. So the first one is when you want to go with this same approach, so you end up having going to standardize it, and the mean, they told us is what, 82. So I have 82 over standard deviation of, we found that that's 6.48. Okay, z is less than 86 minus 82 over this particular standard deviation. Great. So when you check it out, okay, I don't want to put everything on a calculator because I want to show you something, a shortcut. So the top one will be negative 4 over the standard deviation, right? Okay, is less than, this is positive 4 over the standard deviation. Okay, now this is what I was saying earlier, that you can save time. They said that it is what, 4 grams, it differs from the mean by 4 grams. So you can just do negative 4, okay, over the standard deviation, positive 4 over the standard deviation. It is the same thing, okay? But if you want to use all the time to do that, that's also fine. So now we can put everything on a calculator. Negative 4 over 6.48, all right, and that will give us negative 0.617. Is less than, z is less than, then we have positive 4 over 6.48, and that would also give us 0.617. all right, so like I've been telling you, is the phi of the positive 1, okay, minus phi of the negative 1, negative 0.617. Okay, so that means we have phi of 0.617 minus, into bracket 1 minus phi of 0.617. Great. So now we go to our z table and we read the value, 0.617. Okay, 0.617. So 0.6 is here. Then against 1, 0.61 will give you 72.91. Okay, 72.91. Then you go and add the 7. Go to the add column, and then we add the 7. Go to add column, we add 7. 7 is 23. We add that, and then we have 0.7314. So we have 0.7314 minus, to bracket 1 minus 0.7314. And then you put everything on a calculator. What do you get? You have 0.7314 minus, into bracket 1 minus 0.7314. And that, my calculator says I'll get 0.4628. So basically 0.463. Okay, so that is the probability that it differs by 4 grams from the mean. Okay, now let's consider this particular question, and then from there I would want us to solve some approximation questions. Okay, I'll make all the worksheets available so that you can give the rest a try, and yeah, that would be great. Or we should just solve the approximations. Let's see. Okay. All right. Okay, let's give this one a try. Okay, so it says that because we are going to look for the mean and standard deviation. So for this, you get simultaneous equation, then you work it out. That's why they gave you about 5 marks. Okay. So the lengths in centimeters of middle fingers of women in blah 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 have a normal distribution. Mean standard deviation is that 25% of these women have fingers longer than 8.8. So probability of x greater than 8.8 is equal to 0.25. Okay, that's 25%. Okay, then it says that the probability the shorter than what? So x is less than 7.7, that is 0.175, because I think that's correct, right? 17.5% is 0. Yeah, great. So now let's standardize both and then solve it. So that will be probability of z is greater than 8.8 minus mu over standard deviation is equal to 0.25. So we have 1 minus phi of 8.8 minus the mu over the sigma is equal to 0.25. Have negatives this 8.8 minus that over this is equal to, okay, 0.25 minus 1, I think that's negative 0.75. So 8.8 minus mu over sigma is equal to phi to negative 1 of 0.75, since the negatives will cancel out. And 0.75, ladies and gentlemen, it's a critical value, so you don't have to worry yourself. You should get 0.674. Okay, so you can form the first equation from here. So that would be 0.674 sigma plus mu is equal to 8.8. Call this equation 1. Okay, now let's come here. All right, we have probability of z is less than 7.7 minus the mu over the standard deviation is equal to 0.175. So we are going to have phi of 7.7 minus mu over the sigma is equal to that value. Let's go and find the phi to the negative 1 of that side, or you can call it phi inverse, and that would give you, this value is not on the table, therefore negative phi to the negative 1 into bracket 1 minus the value over there. Okay, so I hope in the exam you don't write as huge as the way I do write, so that you can get more space to work it out. Okay, so that value would be 7.7 minus mu over the sigma is equal to negative phi to 1 minus 0.175 will give you, 1 minus 0.175. Great, you have 0.825. Okay, so let's go and read this particular value. 825, is it 825? No, it's not a critical value. So 825, 8250. I have 8264, 8238. I think that is the closest that I can ever get. Okay, yeah. So let's see, 8250 minus 8238. That gives me 12. Okay, so that is 0.93. Okay, let's go and add the 12. We don't have 12 at the add session, but we have 10, so that's what we use, and that is 4. Okay, so we have 0.934. Okay, so that's 7.7 mu over sigma is equal to 0.934. Okay, so we can form another equation. Now it's left with where I'll write that. Okay, let's put that one here. So that's 0.934 sigma. Oh, it is minus, and then I did not write that well. Minus mu. Great. So plus the mu is equal to 7.7. Okay, let's call this equation 2. What is it? Sorry. Okay, let's call this equation 2. Okay, so now this is what I want you to do. You have to solve this simultaneously. Okay, but I don't have a space for that, so I'm just going to put it on the calculator, and then I'll put the answer down. Okay, so in the exam, actually, you should solve it. You should solve. I believe we can all solve a simultaneous equation. So 8.8, then we have 0.934, we have 1, we have 7.7. Great. Now answers are, the sigma is negative 4.23, and then the mu, according to my calculator, is 11.7. Okay, so that is it. Now it says that the lengths of the middle have a normal distribution with the mean and the standard deviation, and then a sample of 5 women is chosen. So this is quite tricky. They have given you a sample, then that would mean that it is definitely going to follow a binomial, okay? Because they are saying a final probability exactly 3, okay, will have the middle finger. Now, you see, the distributions in S1, geometric, binomial, basically that's it, and then the normal distribution. And we know geometric, there's supposed to be some number of failures before you get your first success, and that's not what the story is about. Therefore, it's a binomial distribution. Okay, so if it's a binomial distribution, then exactly 3 would be probability of x equals 3. That would have been 5 combination 3, okay, p to the power 3, q to the power 3. But we do not know the p, we do not know the q, okay, so that's what we are going to look for. So the p is the probability that we are going to work out for, okay, then we can do 1 minus that value, and that will be the q, okay. So they said that is shorter than what, 8.2, so it's less than 8.2. So probability of x is less than 8.2 will be equal to the probability of z is less than 8.2 minus 7.9 divided by 0.44. Okay, so z is less than let's see, that is 8.2 minus 7.9 divided by 0.44, and that will give us 0.682. okay, so from the z table we have 0.68, so let's see, 0.6 again 0.8, 0.6 again 0.8 will give me 75.17 plus, let me go and add the 2 to it, and then 2 on the table gives us 7, so that means we have 75.24, so 0.7524. so this is the probability p. Okay, therefore so p is equal to 0.75824. q will be equal to 1 minus that value, so 1 minus 0.7524 and that gives us 0.2476. Great. So now we can do 5 combination 3. P is 0.7524 to the power 3, and then we have Q, which is 0.2476 to the power. It's not to the power 3, it's to the power 2. Okay, I nearly made that mistake. Okay, so let's put the whole thing on the calculator. 5 combination 3 times 0.7524 to the power 3. Okay, times 0.2476 to the power 2. Great, and there is 0.261. Okay, so that's the answer. The probability that exactly 3 women have middle finger shorter than 8.2 centimeters is actually 0.261. Fantastic. Is there any other? Yeah, the B part says that the random variable x has a normal distribution with a mean equal to the standard deviation. Okay, so let's say mean is equal to standard deviation. Then what? Find the probability that the particular value of x is less than 1.5 times the mean. Okay, so x is less than 1.5 times the mean, but we've said the mean is equal to this sigma, okay, the standard deviation. So that's 1.5 sigma. Okay, we have to normalize this, so that will be z is less than 1.5 sigma minus the mean, but the mean is also sigma, so minus sigma, or what sign am I even writing? Sigma, okay, all over the standard deviation. Now you must work in sigma, sigma, sigma. Don't do sigma and the mu and things. Because if you have different values or variables, then it will be very difficult to subtract. Okay, so you can decide to factor out sigma. So 1.5 minus 1 over sigma. Sigma will cancel out sigma. Okay, so that means you have z is less than 0.5. Okay, and then 0.5 from the table is just what? 0.5 is 69.15. So our answer is 0.6915, and then we are done, because they said that we should find a probability, and that is what we have found. Okay, so now, I mean, these questions, we are not going to solve them. I mean, it's just taking too much time. I'm skipping till we get to the approximation, so that we can apply the approximation to it. So this particular question says that, okay, so the question that I skipped, you should give it a try. Definitely give it a try. Okay, so it says it is found that 10%, okay, of the population enjoy watching historical drama on the TV. Use an appropriate approximation. Now, appropriate for S1, any approximation that you are using is actually normal distribution, okay? To find probability that out of the 160 people, more than 17 people enjoy watching this particular program on TV. So this is what we do. We want to use normal distribution, okay? So we must satisfy the condition for normal. N times P should be greater than 5, and then N times Q should be greater than 5. If this is true, then we can use the normal distribution to approximate, okay? Now, N is 160, okay? And then the probability of success is the one given in the question, and that is 0.1, that's 10%. That means that Q is 0.9. Okay, so let's check these ones out. So 160 times 0.1 is definitely greater than 5, and then 160 times 0.9 is also definitely greater than 5. Therefore, we can use the normal distribution to do this. Okay, now if we need a normal distribution to do this, then we need our mean, and then we need our sigma. Okay, all right. So but we can easily find the variance. So I'm going to use variance. Okay, from there we can take the square root of the variance to get a sigma. Okay, so the mu, or the mean, is just NP, and that will be 160 times 0.1, and that will give us 160 times 0.1. That's 16. and then the variance is NPQ, okay, and NPQ will be 160 times 0.1 times 0.9, and that is like 16 times 0.9, right? Okay, and that is 14.4. Okay, I hope I've done it correctly. Now we are told that it says x is what? More than 17. So it's more than 17 means greater than 17. But now remember that this distribution itself is a binomial distribution that you are going to use normal distribution to approximate. Now if we're going to approximate, then we need to correct all the errors that would come in the calculation. So if you are correcting the errors, then it's you either add 0.5 to it or you subtract 0.5. Now we are told that it is more than 17. That means you are going to add what? 0.5 to that. So z would be greater than 17.5 minus the mean, which is 16, divided by the standard deviation. But the variance is 14.4. Therefore, the standard deviation is the square root of 14.4. All right, and then z will be greater than. Now this part, just put it on the calculator, and you should be fine. And according to the calculator, you should get 0.395. Okay, so this means 1 minus 5 of 0.395. So 0.3 from the table, 0.3 against 0.9, that would be 65, what is it, 65, 17, okay, plus, and then finally we add 5 to that. 5 is 19. Okay, so that means we have 1 minus 0.6536. So put that on the calculator, 1 minus 0.6536, and that, ladies and gentlemen, gives us 0.3464. Okay, so this is the calculation that you are doing. Basically, they want you to, this is how they are going to mark it. They will mark your standardization. They will mark this particular z value, okay, and then they would also check something like this, and then finally your answer. So these are the steps that you need to go through to solve an approximation question like that. Now the next thing is we can use the normal distribution to also approximate geometric. So this question is actually a geometric question. I'm going to solve the question until we get to where we are going to use the normal distribution to approximate the geometric. Okay, it works just like the way we use the normal distribution to approximate the binomial distribution. Okay, so now let's see how it works. Since a pair of fair coin is thrown repeatedly until a pair of tails. Okay, fine. So if you have two coins, then you can have head, can have head tail, you can have tail head or tail tail. So the probability of you getting tail tail is actually 1/4. And it wants us to find what the expected value of x. That means the mean of x, and the mean is 1 over p. And we know that a p is 1 over 4. Therefore, we have 1 over 1 over 4 giving us 4 for your 1 mark. Great. It says now find the probability that exactly 3 truths are required to obtain what? A pair of tails. So probability that x equals 3. Since this is a geometric, okay, that means that there were some failures before you had a success. That's how come I knew that this is geometric. So that means actually the success was obtained on the third truth. That means the first 2 truths we had a failure. So failure to the power 2 before you have a success. Now if your success is 1 over 4, then your failure is 3 over 4. So 3 over 4 square, and then you have your success 1/4. Just put this thing on the calculator. So you have 3 over 4 square times 1 over 4, and that gives you 9 over 64. Great. Now the next thing is that find the probability that fewer than 6 truths are actually required to obtain a pair of tails. So if it's fewer than 6, then it means that x is less than 6. But x is less than 6 is also x is less or equal to 5, because you never get to 6. So it means from 5 way down. Okay. Now we have a shortcut. It's 1 minus q raised to the power 5. So 1 minus 3 over 4 raised to the power 5, and the calculator will tell us the answer. 1 minus 3 over 4 to the power 5, right? Great. So actually I have a video on geometric distribution. You can check it out if you want in detailed explanation of these things. Okay, now this is the D part, the part that I really want to solve. That's why I was rushing through this. Okay, so it says that you are trained the thing how many times? 80 times. Okay, now I forgot to tell you something under the binomial. When the distribution is more than 20, we use normal to approximate these things. Okay, and this is definitely more than 20 is 80. So I mean, great. Now if we are going to approximate this geometric, so we need the mean, which is NP. Now we have already obtained the probability of success to be what 1 over 4, okay, because they are still talking about a pair of tail. So that will be N is 80 times P 1 over 4. I think that is 20, right? Because 4 goes, I think it's 20. And then you have your variance, and the variance is MPQ. Okay, so that's 80 times 1/4 times 3 over 4. And that, I'm not going to use my head to do that. 1 over 4 times 3 over 4, and that will give you 15. Okay, and great. So that would mean that we are told you obtain more than what? 25 times. So x is greater than 25, and I told you that once this is not a normal distribution question but rather a geometric and you are going to approximate it, they said more than 25, so you add 0.5 to that. So z is greater than 25.5 minus the mean, which is 20, divided by the standard deviation. But we know the variance is 15, therefore the root of 15 becomes the standard deviation. Okay, so we put it on the calculator. I have 25.5, okay, 25.5 minus 20 all over root 15. I know some of you might forget and put 15 there. 15 is variance, so just put root 15 and you'll be fine. Okay, so you have 1.42. Okay, so that means 1 minus 5 of 1.42, and then that will give us 1 minus what? 1.4. 1.4 is here. 1.42 is 1.42 is 9222. So 0.9222. 1 minus 0.9222 will give us 0.0778, and that is how we use the normal distribution to approximate the geometric distribution. So if you have been able to watch the video to this stage and you find it useful, please like it, please subscribe to this channel for more content. And as our exam is just around the corner, suggest it to your friends. This might be a life-saving moment for them. Till we meet again, stay safe. Bye for now.